The first experiment in part B is design of a second order Butterworth active bandpass filter. So A is to design and set up a second order active Butterworth bandpass filter for an upper cutoff frequency F2 30 kHz and lower cutoff frequency F1 300 Hz and plot the frequency response. The circuit diagram required is this. So generally, a bandpass filter is a combination of a low-pass filter and a high-pass filter. You can see an IC741 op-amp is being used, and the resistors and capacitors are as shown in the circuit diagram. Let's look into the design. F1, that's the lower cutoff frequency, is 300, and the upper cutoff frequency F2 is 30 kHz. XC2 is equal to R2 at F2. So from this, R2 can be determined, which tallies to 5.6 kilo. So this is obtained after assuming C2 to be equal to 1000 picofarads. Next, R1, R2 and R3 are assumed to be of the same value, and XC1 is equal to R1 at F1. From this, C1 is determined as 0.1 microfarad. The characteristics that is required to be obtained is this. That is, response of a low pass filter and then the response of high pass filter combined together. Let's see how this can be constructed using the Multisim software. So take a new design. Then we need a op-amp. So go for place analog UA741. Press OK. Place it here. We need to flip it for ease of design. So right click on it and then flip vertically. Now we require some resistors and capacitors as it was shown in the circuit diagram. So go to place basic, resistor, the value 5.6K R1 and place it here. Similarly, R2 5.6K, place it in the feedback. R3 5.6K, to rotate it, press Ctrl R. And we require one more load resistor, which is 10 kilo. Rotate it and place it in the output side. Next, we require some capacitors. So select a capacitor. C1 as per the circuit diagram is 0.1 microfarad. And C2 is 1000 picofarad. Now let's start the wiring. So now we need to place the supply, voltage source, and then the ground terminals. So for the input, we can use a function generator. Connect the positive to 5.6K. Negative has to be grounded. So go for place source, power sources. You have a ground there. Click OK, place it here. Similarly, we need ground for this resistor as well as for the load resistor. Now make connections. Now we need to give the power supply for the op-amp. Go for place source. I'm going to use VCC and VEE. So VCC, press OK. It has to be connected to the 7th pin. So rotate it and place it. Similarly, VEE, which is a negative supply, has to be connected to the 4th pin. Close it. Finish the wiring. Let's change the value of the power supplies. VEE is minus 10 volt. VCC is plus 10 volt. And we need an output device to observe the output. So let's take a Bode plotter. So the input terminal of the Bode plotter has to be connected to the function generator and output to the output terminal. And output to the output terminal. The negatives has to be grounded. So with this, the circuit connections are over. Let's provide the input. The input has to be 1 volt peak to peak, a sinusoidal input. And let's try simulating this. So we need to make some adjustments. So the horizontal scale is the frequency. So initial is 1 Hertz and the final could be 1 megahertz. And the vertical scale is going to be the gain scale. That's the output gain. So 0, and let this be something equal to minus 50. And this is the curve we get. Let me reverse the screen. We can also start from 100 Hertz or 10 Hertz. So the curves looks a little bit good. Now let me change the cursor value. So the maximum value will just set, go to the next Ymax. So my Ymax is something like minus 0.088 dB. So I should find out what is my F1 and F2. As per design, the lowest cutoff frequency is 300 Hertz and the upper cutoff frequency is 30 kilohertz. So let me approximately bring it to minus 3 dB. So set Y max less than or equal to set Y value less than or equal to minus 3 dB. So you can see here it's 284. The design value is 300. What you have obtained here is 284.87. So that's my lower cutoff frequency. Similarly, I can find out the upper cutoff frequency. Right click, set Y value greater than or equal to minus 3 dB. Press OK. It shows you 27.648 kilohertz. So as per design, it is 30, and what we are getting is 27.648 kilohertz. So from this, we can determine what will be the bandwidth of the amplifier. So this completes the band pass filter.